The cage is broken, and what was locked inside is moving south. Right now, in the spring of 2026, a fragment of the polar vortex, the same spinning atmospheric prison that normally holds the coldest air on Earth locked above the Arctic Circle, has split from its parent system, descended out of the stratosphere, and anchored itself over eastern Canada. It is not weakening. It is not drifting back north. It is sitting there, fixed and immovable, like a frozen eye staring down at a continent that thought winter was already over. And what that means for the 330 million people living in the United States is something that the models are only now beginning to show in full. But that is not even the real story. Because what you are watching happen right now is not simply a late cold snap, not an inconvenient frost advisory, not a quirk of April weather that will be forgotten by the weekend. What you are watching is the visible surface of something far deeper, far older, and far more connected to global systems than most people will ever be told. The polar vortex disruption of 2026 did not happen in isolation. It was triggered. It was forced into collapse by a stratospheric warming event that scientists at the European Center for Medium-Range Weather Forecasts rated in the top 5% of all such events in the entire satellite record going back to 1979. And that event was itself enabled by a set of planetary conditions, shrinking Arctic sea ice, a dying La Niña, and the early stirrings of what forecasters are now calling a potential super El Niño, that are converging in a way that has not been seen in decades. What is happening above Canada right now is not a weather event. It is a symptom of a planetary system under extreme stress. And the stress is not going away. To understand what is anchoring over Canada and why it matters, you have to first understand what the polar vortex actually is, because the name gives almost no sense of the reality. Picture a spinning wall of wind. Not a gentle breeze, not a storm front, but a continuous counterclockwise rotating band of extraordinarily fast air, rising from the surface of the Earth all the way into the stratosphere, 50 kilometers above your head, trapping the entire pool of Arctic cold air inside it like a cage. That cage rises through two distinct layers of the atmosphere. The troposphere, where all our weather lives, and the stratosphere above it, where the vortex is strongest and most stable in the winter months. When those two layers are in alignment, when the cage is tight and the winds are fast, the coldest air on Earth stays where it belongs, above the polar ice, far from the wheat fields of Kansas, far from the orchards of Michigan, far from the highways of the Northeast. The United States gets mild winters. The system works. But when the cage breaks, when something punches through the stratospheric wall and disrupts the circulation, everything that was locked inside comes pouring out. And in 2026, the cage has broken not once, not twice, but repeatedly, in a cascading sequence of disruptions that began in January and has not fully resolved even now in late spring. Here is what the data actually shows. In early 2026, a sudden stratospheric warming event triggered the first collapse. Temperatures in the stratosphere spiked with extraordinary force. That is what stratospheric warming means. Temperatures in the upper atmosphere rising rapidly. Warming not because it is getting hot in any comfortable sense, but because the pressure dynamics have reversed, destabilizing the polar circulation from the top down. That event was so powerful that it rated in the top 5% of all sudden stratospheric warming events ever recorded by satellite. The vortex did not merely weaken, it split. It fractured into multiple cores, like a spinning top that has been struck off-center, one fragment dropping toward North America, another toward Siberia, both of them dragging their payloads of Arctic air southward. The January-February 2026 North American cold wave that followed was catastrophic. At least 22 people died directly from the cold. Economic damage reached a documented $4 billion. Snow reached Texas and Florida. Newfoundland and Labrador hydro shut down for the first time since 1967. Montreal had its coldest, snowiest single day in nearly a century, and Cleveland, Ohio recorded 8 consecutive days with high temperatures of 17 degrees Fahrenheit or below, tying records from 1893 and 1899, records that are not supposed to be tied in the era of global warming. But the January event, as devastating as it was supposed to end. The stratosphere was supposed to recover, the vortex was supposed to rebuild. That is what normally happens. The disruption passes, the circulation reasserts itself, winter gives way to spring, and the Arctic air retreats. That is not what has happened in 2026. Instead, a residual core of the polar vortex has persisted in the lower atmosphere, stubborn and anomalous, locked over eastern Canada by a pattern of high pressure over the polar regions that is preventing the normal northward retreat of cold air. This is the rare spring polar vortex core that anchors over Canada right now in late April 2026, pulling temperatures 15 to 30 degrees Fahrenheit below seasonal averages across the Midwest, the Great Plains, and the Northeast. New York City recorded its coldest April 4th on record with a morning low of 24 degrees Fahrenheit. Boston registered a hard freeze. Denver picked up 14 inches of snow in a single storm. Minneapolis, Chicago, Kansas City, and Omaha are experiencing temperatures that belong to January. And here is where this story becomes genuinely alarming. Scientists at the ecmwf are not describing this as a passing anomaly. The latest pressure pattern analysis confirms that the residual polar vortex core remains active in the lower atmosphere, centered over North America and eastern Canada, with the final warming event in the stratosphere, the seasonal shutdown of the vortex's upper component, actually releasing the lower core rather than dissolving it. Think about that mechanism for a moment. The stratosphere warming up at the end of winter, the process that is supposed to signal the death of the polar vortex for the season, is in 2026 having the opposite of its intended effect at the surface. The upper cage is opening, but instead of the cold air dispersing harmlessly, the lower core is being set free, unmoored from the stratospheric dynamics that would normally pull it north, free to sit, to persist, to keep funneling Arctic air southward into a continent that has put away its winter coats. Now step back and look at what is behind all of this, because the polar vortex does not break on its own. It breaks when something forces it. And the forcing mechanism in 2026 is not a mystery. It is documented. It is measurable. And it connects this spring polar vortex event to one of the most alarming environmental signals on the planet right now: Arctic sea ice. On March 24, 2026, Arctic sea ice extent hit 13.38 million square kilometers, the lowest extent ever recorded for that date in the entire satellite record, going all the way back to 1979. NASA confirmed separately that winter sea ice peaked at 14.29 million square kilometers in mid-March, tying 2025 for the lowest maximum extent ever observed by satellite. Scientists at the National Snow and Ice Data Center and NASA noted that the 2 years are statistically tied for the worst on record. And what does sea ice have to do with the polar vortex? Everything. When the Arctic is warmer, when the sea ice that reflects sunlight back into space has retreated, and the dark ocean below absorbs that heat instead, the temperature difference between the Arctic and the mid-latitude shrinks. That temperature difference is the engine of the polar vortex. It is the pressure gradient that drives the winds. When the engine weakens, the cage loosens. When the cage loosens, the cold air escapes. Shay Wolf, climate science director at the Center for Biological Diversity, said it plainly in March 2026. The sirens are blaring. And what the sirens are describing is a feedback loop that is now clearly operational. Warmer Arctic means less sea ice. Less sea ice means weaker polar vortex. Weaker polar vortex means more frequent, more severe cold outbreaks in the mid-latitudes. More cold outbreaks in spring when agriculture is vulnerable and infrastructure is unprotected means more damage. The system is not dormant, it is awake. But there is a second global system feeding this event, and it operates from the opposite direction. While the Arctic is warming from above, the tropical Pacific is being reshaped from below. The La Niña that suppressed sea surface temperatures in the equatorial Pacific through late 2025 and into early 2026 has dissipated. In its place, the early signals of what multiple forecasting institutions are calling a potential super El Niño are now being detected. Seasonal ensemble models from the ecmwf are projecting a low-pressure zone over Canada and the northern United States as the dominant pattern for the April-May-June period, the leftover atmospheric footprint of the polar vortex core, stabilized in part by the La Niña to El Niño transition. The Madden-Julian oscillation, a powerful wave of atmospheric energy that circulates the tropics roughly every 30 to 60 days, has been clashing with the descending vortex energy from the stratosphere all winter, complicating the pattern, preventing a clean resolution. The result is what Dr. Ryan Maui of Weather Trader described on April 1st as an exceptionally cold polar vortex anomaly stretching around Greenland, with strong cyclonic troughing feeding the storm systems rolling across the plains and Midwest into spring. What this means, translated from the technical language of operational meteorology, is that the weather pattern Americans are experiencing right now is not being driven by one broken system. It is being driven by 3 broken systems simultaneously: a disrupted polar vortex, a record-low Arctic ice cap, and a shifting El Niño cycle, all reinforcing each other in the same direction. Now go back in time, because this has happened before. The evidence is already in the geological and meteorological record, and understanding what the historical record shows is the only way to understand how serious the present moment actually is. In late January 2019, one lobe of a split polar vortex traveled southward and stalled over central Canada and the north-central United States. The results were catastrophic. Minneapolis recorded a minimum temperature of minus 28 degrees Fahrenheit with a wind chill of minus 49 degrees Fahrenheit, the coldest since 1996. Cotton, Minnesota reached minus 56 degrees Fahrenheit. Cedar Rapids, Iowa broke its all-time record when it dropped to minus 30 degrees Fahrenheit. Moline, Illinois hit minus 33 degrees Fahrenheit, lower than any temperature the city had ever recorded. 21 people died from frostbite and cold exposure. 84 million Americans experienced temperatures at or below 0 degrees Fahrenheit. 3.5 million people experienced at least minus 30 degrees Fahrenheit. Xcel Energy asked 400,000 customers in Minnesota to turn their thermostats down to 63 degrees Fahrenheit to conserve natural gas. Schools, universities, and businesses closed. That 2019 event lasted roughly a week before the upper-level flow redirected the cold westward. It was deadly, it was expensive, and it was supposed to be rare. It was a once-in-a-generation cold snap. That is what people said in 2019. And yet here we are, 7 years later, with a polar vortex core still anchored over Canada in late April, and forecasters measuring the persistence in weeks rather than days. Go further back. The stratospheric polar vortex was first described scientifically in 1952 using radio sonde observations at altitudes above 20 kilometers. Its tropospheric counterpart was documented as early as 1853. That is how long this system has existed in the scientific record, over 170 years of formal observation. And across those 170 years of data, a spring polar vortex core of this persistence, anchored this far south in the lower atmosphere during April, rated among the rarest events in the entire archive. The ecmwf rated the initial stratospheric warming event of 2026 in the top 5% of all such events since satellite monitoring began. Top 5%. That is not a dramatic turn of phrase or a media exaggeration. That is the formal language of the scientists at one of the most respected atmospheric research institutions on Earth. And it is not a statement about a single storm. It is a statement about the behavior of a planetary-scale circulation system. Think about what that means for the people living inside this event right now. Picture the orchard operators in Michigan and Pennsylvania, in New York, the men and women who grow the apples and cherries that stock the grocery stores of the entire northeastern United States. Michigan alone produces about 900 million pounds of apples and 220 million pounds of tart cherries in a normal year. Industries worth hundreds of millions of dollars, built on a growing calendar that begins in April. Those fruit trees are not sleeping anymore. By April, they are blooming, the flowers are out. The delicate pink and white blossoms that will, if everything goes right, become the fruit on your table in September. One hard freeze during the blossom stage, a single night below 28 degrees Fahrenheit at the wrong moment, can wipe out an entire season's yield, not damage it, wipe it out. And right now, across those orchards, farmers are watching frost advisories the way a doctor watches a vital sign they cannot control, monitoring overnight lows with the helpless alertness of someone who has done everything right and is now entirely at the mercy of a system 50 kilometers above their heads. The question those farmers would ask if they could see the full data is the same question the data demands. The monitoring is in place and detection is possible, but prediction is not. Scientists can see the core sitting over Canada. They can model its general behavior. They cannot tell you precisely when it breaks, precisely how far south the next cold pulse goes, or precisely which night the temperature crosses the threshold that ends a growing season in hours. Now move south, to the Tennessee Valley, to the Virginia Piedmont, to the Piedmont of North Carolina, where farms grow strawberries and peaches and early season vegetables for markets that run all the way to the eastern seaboard. Farmers here built their planting schedules around a spring calendar that used to be reliable. The last frost date in Roanoke, Virginia, historically falls in early April. In Charlotte, North Carolina, late March. In Knoxville, Tennessee, mid-April. Those dates are not abstract. They are the line that separates investment from loss. Plant before the last frost and you risk losing everything. Wait too long and you miss the market window. In April 2026, with frost advisories stretching from Tennessee into the Virginia Piedmont and western North Carolina, farms across this region were told to cover or harvest what they could before overnight lows arrived, not next month, right now, in the middle of what should be the height of planting season. The question those farmers would ask, the question every person in the path of this cold core would ask, is not whether this is happening. They already know it is happening. The question is, why is it still here? Why is it still sitting over Canada? Why did it not leave with winter? And here is where the science becomes genuinely unsettling, because the answer is not reassuring. The answer involves the behavior of the jet stream, that powerful river of wind at roughly 30,000 feet that normally acts as a boundary between the cold polar air to the north and the warm subtropical air to the south. A strong jet stream runs roughly west to east, relatively straight, and keeps the cold air where it belongs. But when the polar vortex is disrupted, when the temperature differential that drives the jet stream is reduced by a warming Arctic, the jet stream develops what meteorologists call a high-amplitude wave pattern. It starts to meander. It dips far south in some places and surges far north in others. Those southward dips drag Arctic air with them, deep into the mid-latitudes. And the critical, deeply unsettling detail is that a weak, wavy jet stream does not just produce one cold outbreak. It locks into patterns. It gets stuck. The cold sits where it dips. The warmth surges where it peaks. And the pattern can persist for weeks, for months. This is exactly what the models are showing for April and May 2026. A persistent low-pressure zone over Canada. A cold corridor from southern Canada down into the northern, central, and eastern United States, stable and recurrent, resisting the seasonal transition toward warmth. A study published in the journal Science found that stretching of the polar vortex was associated with more severe winter weather in the United States over the past decade. A study published in Nature in 2018 linked warmer than average Arctic temperatures to cold weather outbreaks in the eastern United States. Another study published in Science in 2021 found that Arctic warming may increasingly disrupt the polar vortex itself, rather than simply the jet stream. 3 separate lines of peer-reviewed scientific evidence converging on the same conclusion that what we are watching in April 2026 is not a random deviation from the norm. It is a pattern. It is a direction. It is the way the system behaves when the Arctic is this warm and the sea ice is this low and the vortex has been this repeatedly disrupted. Scientists are careful to say that no individual event can be attributed with certainty to climate change, but that careful language carries its own warning, because the careful language does not say this is unrelated. It says, we see the pattern, we understand the mechanism, and the mechanism is operating in a world that is warmer than it has ever been during the satellite observation era. The Arctic is warming at roughly 4 times the rate of the global average. The last 3 years have been the hottest globally on record. Samantha Burgess, strategic lead for climate at the European Center for Medium-Range Weather Forecasts, said in March 2026 that Arctic sea ice extent for this year is among the lowest 5 ever recorded. Gilles Garrick, polar oceanographer at Mercator Ocean in Toulouse, France, placed 2026 in the top 3, and crucially, a developing super El Niño in the tropical Pacific is now forecast to amplify Arctic sea ice loss further through the 2026 melt season, setting up conditions for an even weaker polar vortex in the winter of 2026 to 2027. The loop is feeding itself. Low sea ice this winter weakened the vortex and produced the spring cold core anchoring over Canada right now. That same low sea ice, in combination with a super El Niño generating anomalous heat in the tropical Pacific, is on track to produce even lower sea ice this coming fall, which means an even weaker vortex next winter, which means the probability of the next January-February cold outbreak is not lower than what happened in 2026. It may be higher. But the question is not just about the United States. The polar vortex does not operate in a vacuum. When it sends cold air south into North America, it is simultaneously reorganizing the atmospheric pressure pattern across the entire northern hemisphere. As the cold core sits over Canada in April 2026, a high-pressure blocking pattern has developed over the polar regions in Greenland. That blocking pattern is diverting weather systems, redirecting the jet stream's behavior across the Atlantic, and projecting its influence all the way into Europe. In a separate but connected event, a powerful omega block is funneling Arctic air intrusions into Europe, threatening the growing season there as well. The same polar vortex disruption that is sending frost advisories into the Virginia Piedmont is operating as a single connected piece of a hemispheric circulation pattern that is simultaneously disrupting agriculture in Europe. This is not a theory. This is documented atmospheric dynamics. The planetary circulation is one system. When you pull one thread, the entire fabric moves. The NOAA infrastructure model tells its own story. The February 2021 polar vortex event that collapsed the Texas power grid, killing at least 246 people, damaging an estimated $295 billion in property, leaving 4.5 million homes and businesses without power for days in freezing temperatures, happened precisely because a state designed for heat was struck by cold of extraordinary depth. That event revealed the fundamental vulnerability. Infrastructure built for the expected climate cannot survive the new climate. Pipes in homes where winterization has already been reversed for spring are at risk when the cold returns. In warmer climate states like Virginia and North Carolina, homes are simply less insulated for extreme cold. Local utility grids strained by unexpected heating demand spikes in April are grids that were not designed to handle April as a second winter month. The resilience assumption that underpins every infrastructure decision, that the worst-case scenario can be bounded, that there is a known outer limit to the cold, is an assumption that 2021 already proved wrong, and that 2026 is proving wrong again. There is a number that puts this moment in physical scale. The polar vortex core sitting over Canada right now represents a mass of air containing hundreds of millions of cubic kilometers of atmosphere at temperatures between -20 and -40 degrees Celsius at altitude. A pool of cold so vast that if you were to express its thermal energy deficit relative to the air it is displacing, you would need to count in units that have no human equivalent. The entire industrial output of the United States, burning every fossil fuel extracted in a year, cannot generate the heat required to warm that air mass by a single degree. It is moved not by what we do on the surface, but by the geometry of the stratosphere above it, by the pressure waves that travel between the tropics and the poles, by the presence or absence of sea ice thousands of miles away, by the surface temperature of an ocean most people will never see. This is a system operating on scales that dwarf every human structure ever built, and it is behaving in ways that no living person has seen it behave before. The question scientists cannot answer, the question that the best instruments on Earth, the finest ensemble models, the most sophisticated supercomputers in the atmospheric science community cannot answer with certainty is not whether the residual polar vortex core over Canada will continue to funnel cold air southward. It will. It is doing it right now. The question is whether the pattern will simply persist into May, extending the cold anomaly into a month that is historically even more damaging for agriculture than April, or whether a new atmospheric wave will finally push the core northward and allow the seasonal transition to proceed. Meteorologists tracking the pattern as of late April 2026 note the cold pulse should moderate, but there are additional polar vortex anomalies still in the pipeline across the North Pacific, feeding new storm systems across the plains and Midwest. The signal is not clean. The resolution is not certain. This is the part of the story that most coverage gets wrong. The coverage focuses on the current cold outbreak, describes the temperatures, names the cities, gives the forecast for the next 10 days, and stops. But the 10-day forecast is not the story. The story is what the sequence of events in 2026, the January stratospheric warming ranked in the top 5% ever recorded, the repeated polar vortex cores, the record low Arctic sea ice, the spring cold anchor over Canada, the growing El Niño signal in the tropics, the hemispheric pattern over Europe. What all of that together is telling us about the direction this system is moving. The question is not whether this spring's cold outbreak will end. It will. The question is whether the mechanisms that produced it, the warming Arctic, the weakening polar vortex, the jet stream losing its boundary, are temporary or structural. Whether the cold outbreaks of 2019, 2021, 2026 are isolated events or the emerging pattern of a system in transition. The data, as of April 2026, does not support the word temporary. Arctic sea ice has now hit record or near record low maximum extent for 2 consecutive years. The polar vortex has been disrupted by sudden stratospheric warming events rated in the top 5% of the entire satellite record. A super El Niño is developing in the tropical Pacific, forecast to amplify Arctic ice loss further through the coming summer. Dr. Judah Cohen of Atmospheric and Environmental Research, whose polar vortex analysis is among the most closely watched in the scientific community, noted in mid-April that the polar vortex has left for summer vacation early. But its impacts continue to linger. The residual cold core persists. The warm, positive pressure anomalies in the lower troposphere that drive the negative Arctic oscillation, the pattern associated with cold outbreaks in the eastern United States, are forecast to continue dripping downward through late April and into May. The system has not resolved, and resolution when it comes will not reset the underlying conditions that produced the disruption in the first place. Picture that residual cold core over Canada. It is sitting there right now, tonight, invisible from the ground, a spinning low-pressure system 10 to 15 kilometers above eastern Quebec and Ontario, temperatures at its heart around minus 35 degrees Celsius, spinning counterclockwise, pulling surface air northward on its eastern side and pushing Arctic air southward on its western side, channeling a continuous flow of cold toward the Great Lakes, toward the Ohio Valley, toward the Mid-Atlantic. Below it, the farmers in Michigan are checking their blossom temperature thresholds before bed. The shelters in Chicago that thought they were done with winter overflow protocols are keeping those lines open. The highway crews in Minnesota that had already returned their plows to storage are watching the forecast for new snow. And below all of them, 50 kilometers above all of them, the stratospheric polar vortex is completing its final warming, its seasonal dissolution, the process that is supposed to end the pattern, while the lower-level core it leaves behind persists, uncaged, unmoored, and unresolved. The monitoring is in place. The satellites are watching. The models are running. Detection is possible. But the stratosphere operates on scales and in ways that even the best instruments cannot predict with the precision the moment demands. What moves a polar vortex core is not a single force. It is the sum of planetary wave activity, tropical heating, Arctic sea ice feedback, the quasi-biennial oscillation of equatorial stratospheric winds, the Madden-Julian oscillation traveling the tropics in its 30 to 60-day cycle, all of them interacting, all of them influencing the outcome. None of them perfectly predictable at the timescales that matter for the people living under the cold. Scientists know this system is changing. They know the direction. They know the forcing. What they cannot tell you, what no instrument on Earth can tell you right now, is exactly when the next core drops, exactly how far south it reaches, exactly which night the temperature crosses the line that defines the difference between a close call and a catastrophe. And that uncertainty, the fact that a planetary system of this scale, operating on these timescales, connecting the tropics to the Arctic, to the stratosphere, to the surface where you live, is behaving outside the range of what any living generation has witnessed, and that the mechanisms driving it toward further disruption are not temporary but structural. That is the fact that should sit with you long after this video ends. The polar vortex core over Canada will eventually lift. The cold air funneling toward the United States will eventually retreat. The spring will eventually arrive. But the Arctic will still be warmer than it was. The sea ice will still be at record low levels, the Super El Niño will still be developing in the Pacific, and the polar vortex, when it reforms next autumn, will be reforming in a world that has already given it every reason to be weaker, more vulnerable to disruption, and more likely to send another fragment south. The question is not whether this has happened. It is documented. The record is already there. The question the data is now asking, quietly, precisely, in the language of stratospheric pressure anomalies and sea ice extent deviations, measured in units of standard deviations from the 1981-2010 mean, is not whether this will happen again. The question is what is still coming.